Hello, everybody. There is three properties of logarithms that I would like you to know for when I get back. If b, m, and n are all positive numbers and b can't be 1, then we have a product rule, a quotient rule, and a power rule. And if you look what they're talking about, b here, which is the base, can never be 1. So any base higher than 1, and b, m, and n all have to be positive numbers. So this does not work if anything's negative. But if this is the case, if I come to a problem that has the log b of m times n, I can separate this logarithm to be log base b m plus log base b n. And we'll talk about what's actually probably more important is that when we see two logs with an addition sign, we can put them together as one log and make it multiplication. If you think about a plus sign, it turns sideways, it looks like a multiplication sign. If we have a division sign, it looks like a subtraction sign. So if I have two numbers being divided, I can separate them and make a minus sign. The other thing to remember is if you see two logs that are being subtracted from each other and they have the same bases, then I can bring them together and make it m over n. And the last property, which is the power property, allows me to take any exponent that's here and bring it in front of the log base b, and m would stay there. So it allows this exponent here to come out in front of the log. Okay, so of course, what do we do best? We practice. So let's practice the product rule first. There's one log here, it's the base 9, and they want you to expand it out. Well, if I go back here, if stuff's being multiplied together, then I'm going to expand it and use a plus sign. So I'm going to say log base 9, 6. That's the first number. Then I'm doing plus sign, log base 9, 5 is my second number, plus log base 9, the bases never change, 7 squared. Now this is basically done. That's expanded out. The only issue is there's an exponent here. And according to the power rule, if I have an exponent here, I can bring it out in front. So I want to go back and do, this stays the same, 9 to the 6, log base 9 to the 5. But now I'm going to bring this 2 out in front of this log. And then that's it. Now that's expanded. There's no exponents. You use the same base 9 the entire time. Nothing changes. So let's look at this one. You have two options. We definitely have an exponent outside parentheses. So what I'm actually going to do is rewrite this as log base 7, but I'm going to distribute this. So it becomes a to the 12th times b to the 6th. Remember that we need to multiply. Then the directions are to expand, and I know this is multiplication, and if you remember, multiplication turns sideways, looks like a plus sign. So log base 7, a to the 12th, plus log base 7, b to the 6th. Well, the only thing we got to realize is that there is exponents, and where, according to the power rule, do the exponents go? Down in front. So it's 12 log base 7a plus 6 log base 7b. And now you're expanded out, and that's all this directions wants. They don't want you solving anything. They don't want you to do anything. So if you would, pause this video. This one's very easy. This exponent's just with this guy. This exponent's with that. You don't have to distribute or do anything. Can you please pause and try this one on your own? So hopefully that's what you got when you did that one. Okay, let's look at this one. Now we have something new. We have a log, it's to base 5, but we have a number here and a number here. It looks real similar to our quotient property where I have a number over a number. So I'm going to expand it, but instead, since it's division, instead of a plus sign, I put a minus. So it's log base 5, 10 to the 6. We don't need to evaluate anything. All we're doing is expanding. Minus log 5, 7 to the 6. It's almost done, except for there are exponents, which means they have to come out in front. So 10, 6, log base 5, 7. And you're done that problem. That's all they want you to do. Very similar, exact same thing, except we do have a parenthesis with an exponent outside, so we need to give that exponent to both things inside. So the problem's going to start as u to the third, v to the, when I multiply, not add, 9th. Okay, and now it looks exactly like the problem before. Log base 5, u to the third, is it plus or minus? Minus, because a division sign looks like a minus sign. V of log 5, v to the 9th. And then I do have exponents, so where do they go? In front. Okay, so that's expanding. That's all I'm going to ask you to do today is expand either by taking something that's together and writing, expanding it out, or the only other directions we're going to have is this. I'm going to ask you to condense it, which is actually a little more popular. So if you see this, we have 3 logs in the problem, and each are in base 2, which is good, because if they have different bases, we can't do this. The other thing I look for is any coefficient out in front, because remember, where did this coefficient come from? Where did this coefficient come from? It came from this exponent from the problem before. So when I look at this problem here, I want to look for coefficients. There's none here, there's none right here, but there's a 3. So what I want to do is say, I know that needs to go up here because now we're going backwards. So when I condense, think about this, there's 3 of something, I want to condense it, so I'm simply making 1 log. Well, if I go back to my rules, whenever there's a plus sign between logs, it actually means I can multiply. So I'm going to make this 12 times what's here, 5 times what's here, 7 to the third. And since we're condensing, we're not solving or simplifying, we're done. That's all they want. You don't need to make this one really big number because remember, you won't most likely have a calculator for this quiz as well. So let's look at this one, okay? I have to make sure they're in the same base, and look here they are, but remember what's the base if there's no number there? It's actually base 10, okay? So I'm going to make 1 log, and you can put a 10 if you want, you don't need a 10. But then the first thing I do is look for coefficients. So this 10 here actually goes to the top, and the 5 here actually goes up here. And now, since the sign in the middle, if I go back and look at my rules, if I see a minus sign, then I know they need to be divided. And just make sure you see that the first one gets on top of the second number. So when I go back to this one, it's going to be x to the 10th over y to the 5th. And that's it. If you can pick up on that this is log, these exponents have a common number. So if I put these in parentheses, what number could I put out here? They both have a GCF of a 5, and this would need a 2. So this is a little more advanced, you know, like our SAT would probably bring it back together. So now it would be this, but if you get to here, then you're pretty good. Okay, so that's what we're working on is the law of logs, the product rule, the quotient rule, and the power rule, that if they're together by multiplication, they can be expanded by plus sign, division, expanded by minus sign, and if there's ever a variable, it can come out in front. So try some of this on your own.